Welcome back, everyone. We are to the final section in chapter 3. These are graphing transformations, and there's quite a few of them, and some are a little weird, some are not as weird. Let's start with reflecting and translating graphs. When we do a reflection, there's two ways to do it. There's actually several ways to do it, but we're going to focus on just these two here. This first one is if we make y equals negative f of x, then this is going to be a reflection through the x-axis, meaning point by point, they're going to be down here, negative y values. So all the positive y values are not going to become negative and vice versa. In this case, they're all positive. So mine aren't all that great sometimes, so it doesn't look as good as it could, but you get the idea. It's supposed to be like a mirror image based on the x-axis here. Now, when we make the x negative, that is a reflection across the y-axis. So we're going to get something like that. And again, I know that's not the best, but you get the idea that relative to the y-axis, it's a mirror image on both sides. Relative to the y-axis, yeah. Now, it kind of seems opposite because you make y negative, and therefore it's a reflection of the x-axis. And when you make x negative, it's a reflection of the y-axis. So I know it sounds a little backwards, but picture intercepts, right? An x-intercept, you set y equal to 0. Y-intercept, you set x equal to 0. All right. So if we multiply f of x by -1, then we're to this one here. So we're going to reflect through the x-axis. And replace x with negative x, that is going to be reflect through the y-axis. Just like we had here. Now let's talk about translations. And so we have this function here, y equals f of x. And what we're going to do with this +3, this literally brings this up to 3. So each y value is being lifted by 3. In this case, each y value is being subtracted by 2. So all the y values that you had here, add 3 to all of them. And it exactly moves the graph up 3, or in this case, down 2. So functional change to f of x, we're going to add or subtract k. K in this case is the 3, k in this case is the -2. All right. So translations that affect the x coordinates. So opposed to this one, where the translations are affecting the y coordinates, these here are affecting the x. So here we have the same graph. Now they go in the opposite direction. I know that's a little weird. It's going to take some getting used to, but when it's with the x, it's going to be the opposite. So instead of going +3, we're actually going to go back 3. In this case, it's -4, which means we're going to go in the positive direction, 4. Now basically, it's what I just said. It looks like we should move right 3 for the first one and left 4 for the second one. Let's assume the original function is y equals x squared, which is a parabola, which this could be that shape. The second function would be x plus 3 squared. You see that there. With the vertex at -3, 0, which is what we have here, which is 3 to the left of the vertex 0, 0. So this original one was here, 0, 0, and it moved back. And you can say the same thing about this one here. Right. Functional change to f of x, we replace x with x plus or minus h, which is what we did up here, plus or minus h. Remember, it is the opposite sign. Now, if we are reflecting and translating all at the same time, what do we do first? We reflect first. So let me demonstrate to you what I mean by that. Horizontal shifts require the form x minus h. So if you have negative x plus h, you factor out the -1 first, then reflect, and then you translate. So let me show you kind of what I mean by that. So let's take this function here, y equals 2 minus x, and factor the 1 out. What we're going to do first is we're going to write down the parent function. Parent function in this case is root x. Now let's see what that looks like. All right, so that graph looks like that. Now what we're going to do is we're going to reflect the y-axis because we're affecting the x. So that now, put blue here. There we have a reflection about the y-axis. And then the third one, we're going to the right 2. So because it's -2, we're going to move to the right 2. And so it's going to be here. So go to the right by 2. And we'll make this our final graph. So now we're here. And it's going to look like that. As we're looking at that. I know it seems weird, but we have to reflect first. That's the main take from this, and then do the translations. All right, part 2, stretching and compressing graphs, stretching and shrinking. So c times f of x, multiply the y coordinates by c, and f of c times x, we divide the x coordinates by c. Here's some examples of this. Picture this. Let's say that we have f of 2x, and we end up with a 2x equals we have some zeros or something. Well, to get x by itself, I have to divide by 2. Or multiply by 1/2 would be the same idea. So that's why it kind of looks opposite and backwards. Let me show you a better example of what I mean by that. All right, there we are. If you were given a function and asked to graph it, here are the steps. Graph the parent function first. Next, take care of any reflections or cases where you have to multiply or divide. And then finally, translate left, right, up, or down. It is fine to do more than one translation at the same time. Most graphs can be done in 3 steps. All right, so let's talk about what we mean by this. All right, example 1. Given the graph of the function y equals f of x, what are the steps to graph? So for our first one here, for part A, we are going to go, because it's -3, we're going to go to the right 3 steps. B, we are going to reflect the x-axis. Y-axis, it should be y-axis, yeah. Axis, because it's -x. And then after you do that, we are going to go up by 2. Part C. So what we're going to do is we're going to rewrite this like this. So f of -x minus 5 plus 2. So after we have rewritten it, we're going to first reflect the y-axis. Then we're going to go right by 5, because it's minus, and up by 2. Part D. All right, we are for part D, we are going to reflect the x-axis. Because we're multiplying the r by -1. And then we're going to go to the left by 1 because it's plus 1. So the opposite sign of that is negative, which is to the left. In part E, f of 3x, what we're going to do is we're going to divide the x coordinates by 3. It's always the opposite. We could say multiply by 1/3. That means the same thing for us. Part 3. Translations of graphs and functions and their equations. Graph each function using the technique of shifting and so on. Start the graph with the basic function or the parent function and move from there. So I'm going to use a smaller pen just to be clear. So here's our graph, and the parent function, I'll call it g of x, is absolute value of x. That one looks like this here. So that is the parent function. Next up, we are going to reflect this about the x-axis. So again, all of these that I'm doing now are not the final graph. Let's do a different color. Let's do green. So there's the reflect. So reflect the x-axis. And then actually, I'm going to change that. We're going to move that 2 for now. And then we're going to move the vertex. The vertex right now is at 0, 0. We are going to move this, and this is going to be our final graph. We're going to move it right 1, and up 3. 1, 2, 3. So our actual final graph is going to be this one here. Not too bad, but I like drawing in the extra ones in like that, just so I can kind of track where and how it's moving around. All right, let's do one more. I know you see 2 here, but we're just going to do this one here. This one shouldn't even be in your copy. All right, let us start with the parent. It'd be f of x equals root x. And what does that look like? Well, that's going to be here and here. 2. We are at 1.4. 3, we're at 1.7, and so on. So we can kind of see the parent there. Next, we're going to reflect the y-axis. So we're going to be going this way. And let me rewrite the original function. Actually, we can just do this. Square root of negative x minus 5. So I kind of drew this same one before. And so because of the negative there, we're going to reflect it around the y-axis in this case. So here we're here, there, and 2 we're at 4. There, reflected about the y-axis. And now we're going to move it to the right 5. 1, 2, 3, 4, 5. So we're here. And let's use the better pen. At 4 away, So we're looking at this as our graph. So the blue is the final graph. All right. Next, we'll do some problems where we're asked for the function instead. Here, you don't always have to reflect or multiply or divide first. We're not graphing. So let's get started. So we're going to start with y equals f of x. We're going to go to the left, c. So it's going to be x plus c, right? Left is negative, but we have to do the opposite sign, so it's plus c. Reflect about the y-axis. So that means a negative x. Start again. Here we're going to reflect about the y-axis, so that's f of negative x. And then to the right, c, so it's going to be minus c there like that. These two are actually about the same in several ways. Part C, we start with our parent function, and in this case, we're going to move down c, so it's going to be f of x, and then outside the parentheses, minus c. So it's physically going downward instead of left and right. Then reflect the x-axis. That's going to be a negative on the outside, so negative y. This one, we're going to reflect the x-axis, so it's negative y, or f of x. Then we're going to move up c, that's going to be plus c. And first two are about the same, and second two, or last two are about the same as well, is what we say here. Part 4. These examples coming up, find a function that is finally graphed after the following transformations are applied to the graph y equals root x. So this is our parent right here. And so we're going to shift up 2 units. So y equals root x plus 2. Reflect about the y-axis. So this is going to be y equals square root of negative x plus 2. And shift to the left 3 units. So this is going to be y equals square root of negative parenthesis. Because it's to the left, that's going to be x plus 3. And then plus 2. So that's our final equation there. Let's do one more. So y equals root x is our parent, and this one says shift it down by 3 units, so minus 3. Now, if your handwriting isn't perfect, like mine's definitely not perfect, what I do sometimes when I'm writing it is I'll put a little tick down there just to make it clear that that minus 3 is not part of is not under the radical, I should say. Multiply the x coordinates by 2. This one gets a little tricky. When it says multiply x coordinates by 2, we're going to do exactly the opposite, and we're going to take the x coordinates over 2. If you remember from the previous page, we do exactly the opposite. All right. Suppose that the x-intercepts of the graph are here and here, negative 3, 0, and 2, 0. What are the x-intercepts of the graph? F of x minus 4. So this is to the right, 4, which means add 4. So these coordinates become 1, 0, and 6, 0. So the whole graph, whatever it was here, and it moved to the right. And so the x coordinates are going to reflect that. All right, last page for this section and this chapter, actually. The point negative 15, negative 6 is on the graph of y equals f of x. Start here. Let's utilize some space. A. What is a point on the graph, meaning based on this one, of y equals g of x, where g of x is f of x minus 1. This means all of the y values are going to go down 1. So this means that negative 15 doesn't change, but the y value gets subtracted by 1. So negative 6 minus 1, negative 7. What is a point on the graph of y equals g of x where g of x is 1/6 f of x? Well, that is literally going to take my y value and divide it by 6. So x is not effective. However, -6 divided by 6 is going to be -1. Part C, what is the point of the graph? Well, where f of x equals negative f of x. That means the y is now the opposite sign. So -15, comma, instead of -6, it's now a +6. Part D. Okay, so x plus 12. So actually what I'm going to do is I'm going to subtract 12 from the x. It's the exact opposite. So -15 minus 12. -15 minus 12, -27. And the y coordinate stays the same. Part E, let's go over here. Part E, f of -x. That means the x is now going to change the sign. -15 is now -6. And finally, if I multiply 7 times f of x, well, that's 7 times y. So the x coordinate won't change. However, the y coordinate is going to get multiplied times 7. So that's -42. It's not too bad. Just you may need to go through this again. There's quite a few things to notice. Thanks.